Hello and welcome to this video. In this video we'll be learning about quartic graphs and we'll be making some generalizations about other polynomial graphs as well. Right, so the word polynomial comes from the fact that when you multiply brackets like so, whether doesn't matter what the roots are next to them, these are just random numbers I'm writing here. So this was uh, a cubic graph because this will give us the highest power of x cubed, and here we said a is positive and so on, right? If you remember, we discussed cubic graphs. So we can make some generalizations about other powers of x as well, as long as the power of x here is an odd power. All right, so when you have an odd power, so it could have been x power of 1, x power of 3, or x power of 5 or 7, doesn't matter. The, the end of your graphs will be in these two quadrants here. All right, quadrant 1 and quadrant 3. All right, so if uh, it's got a power of 5, there may be up to 5 roots, or there would be odd number of roots. All right, so 1, 2, 3, 4, 5. All right, we're not going to discuss higher powers in this book here, but I'm just saying that the end of the graphs will end up there in quadrant 1 and in quadrant 3. If when the powers are when the highest power is odd. Highest, I must emphasize, this is talking about the highest power of x. All right, so now we're coming to discuss quartic graphs, where the highest power of x is 4. All right, so when you have highest power of 4, obviously this polynomial, it doesn't matter, it's not important what the smaller powers of x are, whether they exist or not, it's not important. If it's like so, you can have up to four roots. So if you remember, when we had x squared, we always had two roots or no roots in some cases, or tangent. So the highest number of solutions is related to the power. Okay, so this could have been, because that could have been factorized into only two brackets. You couldn't have more than two brackets. So x plus 2 and x minus 1 doesn't matter. uh, we make a generalization. I'm making a generalization here. Look at the end of these endpoints here. When the power is now even, okay, so when we have even power rather, the highest power is even, the highest power is even, the end of the graphs will be either both positive or both negative. So for when you have a quartic graph, when A is positive, you will have such shape. The end of the graph will be positive. So it may have four solutions or just two solutions. So 1, 2, 3, 4. All right, those depends on what the number, when you factorize them, what number is going to the brackets and come out of the brackets. So it may have two solutions if it's just tangent at 2 points. All right. So the number of solutions for a quartic is maximum 4. May have two solutions, or it may have no solution at all. Right. It may just be uh, above the x-axis. And when a is negative, I'll show you in the next slide. So when a is positive, it may have just it may not have a solution or not have one. So it will have three turning points. The question says three turning points. May have two solutions when a is positive. Now there is a case where a is actually negative as well. We'll come and see this. So when a is negative, we said y values are both this third quadrant and the fourth quadrant. Okay, so you better remember that. Just like when we had a times x square, and I said that would have a sad face. Now it depended whether the x-axis was here or here. In any case, the end of the graph, these endpoints where the line will go into infinity, on this side is going to minus infinity when x is negative, x is less than 0, y will be less than 0. When x is positive and very large value, y is still negative value. So this, do you see the similarity when, because the power here is a even number, and power for this graph, the highest power of x is also even, and a here is me. All right, so with that, when you have to plot the graph for this, let's have a look at this example here. First of all, when we take these values out of the bracket, you end up with these numbers, with these solutions. So there are four solutions there. And when x is 0, when we substitute 0 here, we're gonna get y equals to 1 times 2 times minus 1 times minus 2. So minus and minus cancel. We get a positive 2 times positive 2, which is a plus 4. That's where that 4 comes from. So that's the y-intercept when x is 0. So let's plot it. We're gonna draw x and y axis. Let's do it with the... Alright, once you've plotted the x and y axis, you put the solutions on the number line, and you say, all right, I'm checking what's the coefficients of x. They're all positive. That's great. So I'm gonna have the end of the graphs. I'm gonna put the ends there already. So, and there are no repeated roots. So therefore, it has to cross the line. It have to go there, come here, and cross the x-axis, make a U-turn here, and come back up here. Right, so try to draw a smooth curve rather than edge. We don't want sharp corners on this polynomial. All right, so, and we said the y-intercept is a 4. Okay, so y value is 4 when x is 0. X is 0 on the y-axis. All right, so that's the shape of general shape of the graph. Now, it doesn't matter how, in what scale you draw it on, as long as the general shape is correct. Now in this next example, we have a repeated root at x equals to minus 2. So when x is minus 2, we have to take care of the repetition. And x is, the other solution is 0 and 3. When you substitute 0 for x, y value will be 0, because this extra 0 at the front doesn't matter what the other brackets are. When you times them by x equal to 0, y value will be 0. So it will go through the origin, right? Its y-intercept is through the origin. So let's draw the graph. First, you draw x and y axis. I know I will have one of the, we'll have a y-intercept there, and minus 2 is where the bounciness will happen. All right. So you check the coefficient of x. Actually, we have a negative coefficient here, and the other coefficients are all positive. Therefore, this graph will have its endpoints, end of the lines, in these two quadrants down below the x-axis, right? And at x equals to minus 2, let's say this is a minus 2, it will have to bounce off the x-axis. So it will come here, it will bounce off. There is no other roots below 0, so once it's bounced off, it will go through the origin, and well, that's because it's one of its roots as well. It counts as the y-intercept and the root. And at 3 you will have to cross again because it's not repeated. This root is not repeated. You will cross this line and bam, flies away. Alright, so this point is 3, this point is 0, and this point x value is minus 2. All right, so make sure your bounciness is clear. It bounce off the x-axis. All right, so that's another way of thinking about it. So let's look at the next example. We have two repeated roots here. All right, so x when x is 1 is repeated and when x is 3 is repeated. When you substitute x equals to 0 into this equation, y value will be minus 1 squared times minus 3 squared. That's why you get a positive 9 here. So let's plot this. First we draw the x and y axis. Then we say y-intercept is going to be 9 somewhere up there. And let's put 1 and 3 here. So 1 and 3 are here and here. I'll check the coefficients of x. They're all positive, so the end of the graph will be at these 2 points. It seems, because this is a repeated root, I'm gonna draw the end line here. It's gonna come down here, and it's gonna come to 1, bounce off. It's gonna have to make a U-turn, because the other end of the graph is over here. So it bounces off 3, makes a U-turn at some point. We don't know. It's not essential for you to know at what's the turning point there. Once you learn differentiation, you will figure it out. All right. So that's the general shape of the graph. All right. So good luck drawing these and plotting Quartic graphs. I'll see you in the next video.